Is your game lagging or running slowly? It's incredibly frustrating, especially when you've already compromised on your assets to boost performance, but still cannot get the expected results. I struggled with this myself, but now I've found the best solutions. In this tutorial, I'll show you the top 4 methods to make your game run buttery smooth. Let's get started. Number 1. LOD, or level of detail. LOD is a technique that optimizes performance by swapping out high detail models with lower poly versions as objects move farther from the camera. This means that only the objects near the player are rendered in full detail, reducing the GPU's workload. To do this, select your mesh, go to Geometry, and adjust the LOD bias. Increasing it keeps high detail models visible longer, while decreasing it switches to low poly models sooner for better performance. Number 2. Visibility range. Visibility range enhances performance by limiting how far objects render based on the camera's distance. In Godot, you can set this range in the inspector by adjusting the begin and end properties in the mesh node. Number 3. Disabling shadows. When you enable real-time shadows on a directional light, the engine calculates those shadows on the fly, which can put a heavy load on performance. Disabling shadows improves performance, but then your game might lose visual depth. In this case, you can use Lightmap GI. Lightmap GI precomputes lighting for static meshes, baking the light and shadows into textures, so the engine doesn't need to calculate them in real time. This drastically improves performance while still providing lighting for your static objects. To add Lightmap GI, first, select your directional light and set its bake mode to static. Then, add a Lightmap GI node to your scene. Next, select all the objects you want to include in the baking process and unwrap them for light maps. With the Lightmap GI node selected, go to the Tweak section and set the Texel scale to 0.2. A higher value will make the lighting sharper, but keep in mind that it may cause the engine to crash. Once you've adjusted the settings, click Bake Light Maps and save your project. Now, you'll notice that your world looks significantly more polished and vibrant. If some objects remain unbaked, select them, unwrap them again, and click Bake Light Maps once more. Now your game looks more realistic without any performance lag. For static objects, using Lightmap GI is the perfect way to achieve maximum visual quality without slowing down your game. Make sure to leverage this technique for the best results. Number 4. Occlusion Culling. Occlusion culling optimizes performance by not rendering objects hidden behind other geometry. In Godot, this means that if an object is completely blocked from view, it won't be processed, which minimizes rendering work and boosts frame rates. To enable occlusion culling in Godot, first open your project settings and activate Advanced Mode. Then, navigate to the Rendering section. Find the Occlusion Culling options and enable Use Occlusion Culling. Now add an occluder instance node to your scene, then click Bake Occluders and save your work. This precomputes occlusion data so that Godot can skip rendering objects hidden from view. And that's it. Now we know how to reduce GPU load by using LOD, enabling visual range culling, implementing occlusion culling, and leveraging Lightmap GI instead of real-time directional light shadows. With these techniques, your game will run smoother and more efficiently while still looking great. If you found these tips useful, please like and subscribe. Thanks for watching, and happy coding!